I'm Rob Page. I'm an emeritus professor at Arizona State University, and I'm going to be talking to you today about the Song of the Queen. I'm going to be letting you know the intricacies of it and also why I call it a song. If you want to know more about me personally, you can check out my Wikipedia page. It'll give you more information. The Song of the Queen was the final chapter in this book shown here, which is published by Oxford University Press. And the content of what I'm going to talk about today was drawn directly from the last chapter. The inspiration for what I'm talking about today, however, came from a poem by E.B. White that was published in the New Yorker in 1945, and it was called The Song of the Queen Bee. And I'm going to read it. This is just part of it. When the air is wine and the wind is free, and the morning sits on the lovely lea, and sunlight ripples on every tree, then love in air is the thing for me. I'm a bee. I'm a ravishing, rollicking, young queen bee. That's me. I wish to state that I think it's great. Oh, it's simply rare up in the upper air. It's the place to pair with a bee. Let old geneticists plot and plan. They're stuffy to a man. Let gossips whisper behind their fan. Oh, she does? Buzz, buzz, buzz. My nuptial flight is sheer delight. I'm a giddy girl who likes to swirl, to fly and soar, and fly some more. I'm a bee, and I wish to state that I always mate with whatever drone I encounter. E.B. White wrote this poem in response to an article that appeared in the newspapers across the United States announcing the development of artificial insemination technology of queen honeybees. It was in response to the old geneticist shown here, Harry Laidlaw, who had developed the technology at the University of California, Davis. Queen mating is really one of the most fascinating features in biology and natural history. Queen takes somewhere between 1 and 3 mating flights within a few days after she emerges from her cell as an adult. On each of these flights, she can mate with 10 or maybe even more males as she flies through the air. She then takes the sperm from these different male mates and she stores them away in a special little organ in her abdomen, and she never mates again. Here's the roadmap of what we're going to cover today. I'm going to start with natural history. I'm going to give you some basic natural history of bees. I'm going to tell you how bees make a queen bee. You know, they can make a worker bee or they can make a queen. I'm going to talk about how they make a queen. Then we're going to address the question, do queens mate? Sounds like a silly question to us, but it wasn't a silly question 300 years ago. Where do they mate? This took time to figure out. People didn't know where they mated. It was a big mystery. How do they mate? Just the actual mechanics of mating was not anything that had been observed until really just within the last 4 or 5 decades. How many times do they mate? How do they use the sperm from the different mates that they mate with? And why do they mate so many times? A typical colony of honeybees consists of a single queen. She's the mother of most all the bees in the nest under normal conditions. A few drones, that could be from a few to a few hundred at any given time in the colony, and anywhere from 10 to 30 or 40,000 workers. The workers are the individuals that are responsible for the upkeep and the maintenance of the queen and the nest, and they do all the work. Honeybee nest is composed of parallel vertical combs, such as shown here, full of individual hexagonal cells, which you've all seen. And the cells themselves are the receptacles for their food. The pollen stores, which are their protein resources, and stored honey, which is their carbohydrate resource. It's also the substrate on which all of the social interactions of the bees take place. It's their social stratum. Bees also have a division of labor. That simply means that some bees do different things. They have different tasks that they perform. And these are age-based, meaning that as a bee ages, she changes the kinds of things she does. and she'll go from one set of tasks, perhaps feeding larvae, to another set of tasks, which might be cleaning dead bodies out of the nest, or maybe guarding the entrance. Within a colony, you find bees of different types. There's 3 fundamental types you'll see. One division of these types is based on gender. You have males, which the large individual on the right-hand side is a drone. And you have the females, which are the 2 on the left. The upper one is the queen. She is the mother of all the other bees. She lays all the eggs. And the workers, which are the one shown below, which are the ones who, as I said before, have a division of labor and take care of the nest and do basically all the tasks that are performed. These are the 3 types compared across. The one on the left is the worker, and she's the smallest of the 3. She's just about half the size of a queen. She weighs about 100 milligrams when she emerges from her cell as an adult. The queen in the middle, she's longer and slender. She weighs about 200 milligrams when she emerges. The one on the right is a drone. Drones are large, they're robust, they're almost the same size as a queen, and they're just as heavy. They weigh about 200 milligrams when they emerge from their cells as adults. The interesting thing is that they all are derived from the same basic eggs. There's no difference in the eggs that give rise to workers, queens, or drones. When the eggs are laid, they're the same. There's nothing in them that differentiates them. The queen has a little spermatheca. It's an organ in her abdomen. In Greek, that means sperm purse. She stores the sperm from her male mates, and she doles them out and uses them over her lifetime of 1 to 3 years. When she lays an egg, she can either fertilize the egg by releasing sperm to fertilize the egg, as occurs on the right-hand side. They give rise to females. So fertilized eggs make either workers or queens. The only difference between those is their development and the food that they get fed. If she doesn't fertilize the egg, it develops into a male. You can see the male is on the bottom on the left. The male has only a mother. He has no father. He has half the number of chromosomes when he initially develops compared to the worker and the queen. Workers have legs that are specialized, that are very different from the legs of the queen. Here are the hind legs of a worker, and it shows the different parts that you only find on the legs of the worker. There's a pollen press. There's a pollen brush. The pollen brush is used to brush the pollen off of the body that adheres to these branched hairs that are all over the body of the worker. When she goes into a flower, her body picks up the pollen. She gets out, she takes that brush, she brushes her body, and she puts it into the corbicula, which is the one on the right, B. It's basically a receptacle that pollen gets stuffed into. If you've seen those big balls on the legs of returning foragers, those balls of pollen are stuffed into the corbicula. On the bottom, you see the pollen press. The pollen press is what is used to press the pollen up into the corbicula so that the bees can then transport the pollen back to their nest. The queen and the worker, the females, they also have a weaponized ovipositor. An ovipositor is a very common feature among female insects. It's used to deposit eggs. And it's across many orders of insects, they still have some kind of an ovipositor. In the Hymenoptera, the wasps, bees, and ants, the ovipositor is often modified into a weapon. It's a defensive weapon, or it's used in the case of some wasps to sting a potential host. They'll sting it, paralyze it, lay their eggs on it, and then the eggs will hatch and the larvae will consume the host that has been immobilized. The upper left shows the queen. The queen's stinger, or her ovipositor, is curved and smooth. And you see that's different from the ovipositor of the worker, which is shown right below it in 2 places. The worker's ovipositor is straighter and it's barbed. Now, a queen only uses her sting soon after she emerges as an adult, she uses it in fights, contests with other queens. As you probably know, there's a fight to the death by all the different queens that come out at one time, and they're fighting using this ovipositor, this stinger. They have to be able to live, so they have an ovipositor that can be deposited through the integument of the other queen. That would be the hard shell that they have on the outside, as you can see on the worker to the right, but be able to retract it and use it again. Whereas a worker, her barb sting, as you see on the left, when it is embedded into the skin of a predator or a beekeeper, it gets stuck inside the skin. And the worker, as they try to move away from it, they actually leave the stinger intact inside of the individual that they were stinging in defense of their nest, and they become disemboweled. You can see that their intestines are coming out. So when you get stung the next time, you think about how it hurts you, but how it actually kills the worker. Males, on the other hand, have what I call a weaponized sperm delivery system. And this evolved because a colony over the course of a season may produce up to 20,000 drones, but a colony will only produce somewhere between 1 and maybe 3 queens. So there's a huge ratio bias out there for drones over queens that are flying around and trying to find each other to mate. So this puts intense competition on the males to be able to, first of all, locate a mate, and then once they get them, dominate them in a way that they can actually deliver their sperm into the queen and father the potential queen that might be her daughter down the road. So I calculated once there's about a 2 or 3 times in 1,000 chance that an individual male is actually going to be able to successfully mate with a queen. So there's huge competition. This competition has resulted in drones having very strong, robust bodies, as you saw. They have an explosive ejaculation. When they deposit their semen inside of a queen, it's a very forceful and explosive ejaculation. They also have coagulating mucus, a plug that they insert behind the sperm. The sperm goes in, then this mucus plug comes in. You can see that on the right, the object on the bottom. That's a mucus plug, and that's put in behind the sperm lobe to kind of lock it in. And then the other thing happens is the end of the we call it the endophallus. That's the penis of a drone. The endophallus actually breaks off. That's this part up here. It breaks off along with the mucus plug, and this part here is left behind in the queen. We call that the mating sign. This whole big blob is left there, and it's sits there as a possible way of blocking and preventing others from mating with the queen. Then when you look at the sensory systems and compare drones, queens, and workers, you'll notice some interesting differences. The number of eye facets that they have are different. Eye facets, if you've seen pictures of insect eyes with all those little like hexagonal individual simple eyes all put together. Well, those are the eye facets. And drones have about 8,600 of them. And these are for visual detection and especially for detecting movement. A queen has about 4,500. She has roughly half of what a drone has. She doesn't need to have that kind of visual acuity. And then workers are somewhere in the middle between the queens and the drones with about 6,900 eye facets. Antennal segments, the antennae come out and they have all kinds of sensory receptors on them. That's a good part of how they sense the world. The antennal segments for queens and workers are 10. They have 10 segments to an antenna. Drones have 1 extra segment, which lets them pack in more receptors that they can use for detecting queens when they're flying through the air. The chemoreceptors, they have 18,000 chemoreceptors per antenna. These chemoreceptors are tuned to picking up the scents that the queens are emitting as they fly through the air. So they're flying through the air with these eyes that are tuned for detecting movement. They have these intense chemoreceptor systems that are picking up the odors of queens that might be out there. Compared to the queen with 1,600, she doesn't need very many because she doesn't do much except take that one mating flight. And 2,600 for workers. Workers need it because they detect flowers, the odors of flowers that they use for finding the floral sources and collecting resources from them.